building modern applications, the way your API responds to requests is crucial. A well-structured API response improves client-side error handling, making life easier for front-end developers. It also enhances readability and maintainability, ensuring that future developers can quickly understand and work with your code. Debugging and logging become more straightforward, allowing issues to be spotted and resolved efficiently. By standardizing API responses, you create a foundation for robust, scalable, and maintainable applications. Let's explore how Spring Boot helps you achieve this with generic API responses and global exception handling. Before diving into API response handling, it's important to set up your Spring Boot project with the right dependencies. Using Maven, you include Spring Boot Starter Web for REST APIs, Starter Validation for input checks, H2 Database for in-memory testing, Data JPA for database interactions, MySQL Driver for production storage, DevTools for development convenience, and Starter Test for unit testing. These dependencies lay the groundwork for building, validating, and testing your API efficiently. With this setup, you ensure your application is ready for robust development and seamless integration. For persistent storage in production, configuring MySQL is essential. You set the datasource URL, username, and password in your application properties. Additionally, you specify the driver class name and Hibernate dialect for MySQL. Enabling SQL query logging helps with debugging, while automatic table creation and updates streamline schema management. These configurations ensure your Spring Boot application connects reliably to the database, supports efficient data operations, and is ready for real-world deployment. Employee entity forms the core of your application model. Defined with JPA annotations, it includes fields for ID, name, and department. The ID is auto-generated, while name and department are marked as not null to ensure data integrity. Getters and setters provide access and modification capabilities. This entity represents employees in your database, serving as the foundation for API operations such as create, update, and retrieve. API Response T class standardizes API responses in Spring Boot. It uses a generic type T, allowing flexibility to return any data type, such as an employee object or a list of employees. Key fields include success, message, data, errors, error code, timestamp, and path. This structure ensures every response, whether successful or erroneous, follows a consistent format, making client-side handling and debugging much easier. Using a generic type in API response allows your API to handle various data types seamlessly. Whether you need to return a single entity, a list, or any other object, the generic type T adapts to your needs. This flexibility reduces code duplication and simplifies controller logic, making your API more maintainable and scalable. It's a best practice for modern REST-TFL services. Each field in API response serves a specific purpose. The success boolean indicates if the request was successful. The message provides context about the result. Data holds the actual response content, while errors list what went wrong. Error code classifies the error, timestamp records when the response was generated, and path shows the request URL. Together, these fields create a comprehensive and informative response for every API call. Custom exceptions like resource not found exception and response not found exception help you handle specific error scenarios. By extending runtime exception, these classes allow you to throw meaningful errors when resources are missing or responses cannot be found. This approach improves clarity and control over error handling in your application, making it easier to debug and maintain. The Global Exception Handler class centralizes exception handling for your entire application. Using at-rest controller advice, it intercepts exceptions thrown by controllers and returns standardized API response objects. Methods annotated with that exception handler handle specific exceptions, ensuring consistent error formatting and improved client experience. This setup streamlines error management and keeps your controllers clean. The at-rest controller advice annotation combines at-controller advice and at-response body. It allows you to handle exceptions across multiple controllers and ensures responses are serialized into JSON or XML. This makes it ideal for REST APIs, providing a global mechanism for exception handling and response formatting. By using at-rest controller advice, you simplify error management and enhance API reliability. The at-exception handler annotation defines methods that handle specific exceptions. When an exception is thrown, Spring looks for a matching at-exception handler method and uses it to process the error. This prevents default error pages and allows you to return structured JSON responses. It's a powerful tool for customizing error handling in your Spring Boot application. When resource not found exception is thrown, The corresponding exception handler method returns an API response object with error details. This ensures users receive clear, informative error messages instead of generic server errors. By handling exceptions this way, you improve the user experience and make debugging easier for developers. Global exception handling in Spring Boot ensures that all controllers follow the same error management logic. At rest, controller advice defines the global handler, while at exception, handler methods specify how to process different exceptions. This combination guarantees consistent error formatting and response structure, making your API more reliable and easier to maintain. The response util class simplifies the creation of standardized API response objects. It provides reusable methods for generating success and error responses, making controller code concise and consistent. By centralizing response logic, response util reduces duplication and ensures every API response follows the same structure. The success method in response util creates a successful API response object. It sets the success flag to true, includes a message, attaches the data, and records the request path. Errors are set to null, and error code is 0. This method ensures every successful response is clear, informative, and consistent. Response util provides two error methods, one for a list of errors and another for a single error message. Both methods create an API response object with the success flag set to false, include error details, set the error code, and record the request path. This approach ensures all error responses are structured and easy to interpret. Employee Controller manages API endpoints for employee operations. It uses response util to return standardized responses for actions like updating an employee. By leveraging the service layer and global exception handling, the controller remains clean and focused on request processing, delegating business logic and error management to dedicated components. The updates employee endpoint uses a put mapping to update employee records. It receives the employee ID and updated data, calls the service layer, and returns a response entity with a standardized API response. If the employee exists, the response indicates success. If not, a resource not found exception is thrown and handled globally. The employee service contains business logic for updating employees. It checks if the employee exists, updates their information, and saves changes to the database. If the employee is not found, it throws a resource not found exception. This separation of concerns keeps your application organized and maintainable. The Employee Repository interface extends JPA repository, providing data access methods for employee entities. Annotated with that repository, it enables CRUD operations without boilerplate code. This abstraction simplifies database interactions and supports efficient data management in your application. The Demo Application class is the entry point for your Spring Boot application. Annotated with that Spring Boot application, it enables auto-configuration and component scanning. The main method launches the application, initializing all components and making your API ready to serve requests. Creating the employee table in SQL ensures your database is structured for API operations. The schema defines fields for ID, name, and department, with sample records inserted for testing. This setup supports CRUD operations and provides a foundation for real-world data management. To update an employee, you send a PUT request with the employee's name and department in the request body. The endpoint processes the input, validates it, and updates the record if the employee exists. This operation demonstrates how standardized API responses and global exception handling work together. When an employee is successfully updated, the API returns a structured response. The success flag is true, a message confirms the update, and the data field contains the updated employee information. Errors are null, error code is 0, and the timestamp and path provide context. This clear response helps clients process results efficiently. If the employee with the provided ID does not exist, the API returns an error response. The success flag is false, the message indicates the resource was not found, and the errors field lists the specific issue. Error code is set to 404, with timestamp and path for debugging. This structured error helps clients handle failures gracefully. Standardized API responses make client-side development easier. By using a consistent structure for both success and error cases, you ensure predictable results and simplify integration. This approach reduces confusion, speeds up development, and enhances the overall reliability of your application. A standardized response format makes debugging and logging much easier. With clear error messages, timestamps, and request paths, developers can quickly identify and resolve issues. This transparency supports efficient troubleshooting and ensures your application remains robust in production. Adopting generic API responses and global exception handling, you enhance the maintainability of your codebase. Future developers can easily understand response structures and error handling logic, making updates and improvements straightforward. This approach supports long-term scalability and reduces technical debt. With response util and global exception handling, controller logic becomes simpler and more focused. Controllers delegate response formatting and error management to utility classes and handlers, allowing them to concentrate on processing requests. This separation of concerns leads to cleaner, more organized code. The generic type in API response allows your API to handle various data types, from single entities to lists or custom objects. This flexibility supports diverse use cases and reduces the need for multiple response classes. It's a key feature for building scalable and adaptable APIs. Global exception handling centralizes error management, ensuring all controllers follow the same logic. This reduces duplication, improves consistency, and makes it easier to update error handling strategies. Centralization is vital for maintaining large, complex applications. Standardized responses and global exception handling provide a consistent experience for API clients. Clients can reliably interpret responses, handle errors, and display meaningful messages to users. This consistency builds trust and improves the usability of your API. By using response util and generic API response, you reduce boilerplate code in your controllers. Response formatting and error handling are handled by reusable methods, freeing controllers to focus on business logic. This efficiency speeds up development and keeps your codebase clean. Standardized API responses and global exception handling align with res-tful principles. They ensure predictable, structured communication between client and server, supporting stateless interactions and clear resource management. This adherence to REST best practices enhances interoperability and scalability. Enabling SQL logging in your Spring Boot configuration helps with debugging database operations. By printing SQL queries, you can track data changes, identify issues, and optimize performance. This transparency is essential for maintaining reliable and efficient data management. Using H2 database for in-memory testing allows you to validate API operations without affecting production data. It supports rapid development and testing, ensuring your application works as expected before deployment. This approach is ideal for unit tests and integration tests. Spring Boot Starter Validation ensures input data meets required constraints. By annotating fields with it not null and other validation annotations, you prevent invalid data from entering your system. This proactive approach improves data integrity and reduces runtime errors. Spring Boot DevTools enhances development convenience by enabling hot reloads and quick feedback loops. This tool speeds up development, allowing you to see changes instantly and iterate rapidly. It's an optional but valuable addition for efficient coding. Spring Boot Starter Test provides tools for unit testing your API endpoints and business logic. By writing tests, you ensure your application behaves as expected and catch issues early. Testing is a critical part of building reliable, maintainable software. Configuring MySQL for production ensures your application can handle persistent storage and real-world data. By setting up the datasource, driver, and dialect, you prepare your API for deployment and scalability. MySQL integration is essential for robust, enterprise-grade applications. Inserting sample records into the employee table allows you to test API operations and validate functionality. Sample data provides a realistic environment for development and debugging, ensuring your endpoints work as intended before going live. Global exception handling allows you to manage multiple exception types in one place. By defining specific exception handler methods, you can tailor responses for different errors, improving clarity and control. This approach supports complex applications with diverse error scenarios. Including the path field in API response helps with debugging by showing the request URL. This information allows developers to trace issues back to specific endpoints, speeding up troubleshooting and improving transparency. The timestamp field in API response records when the response was generated. This helps track API activity, monitor performance, and identify timing issues. Accurate timestamps are valuable for auditing and debugging in production environments. Generic API responses and global exception handling in Spring Boot provide a powerful foundation for building reliable, maintainable, and scalable APIs. By standardizing responses, centralizing error management, and leveraging utility classes, you create a robust framework that supports efficient development and seamless client integration. Adopt these best practices to elevate your Spring Boot projects and deliver exceptional API experiences.